Good morning, everybody. All right, let's do it. So for today, we're going to do lesson 6, complex numbers as vectors. Yesterday, this was our do now. If you didn't get a chance to do this do now, go ahead and do it by yourself. Here, let's go to the next page, and to really understand this idea of what we did yesterday, let's have this in our notes before we continue on. Okay, so take a second and copy this down. Lesson 6, it says, notes, another way we can represent a complex number in the complex plane is a vector. So I'll describe what a vector is. A vector, some vector AB is the directed line segment from point A to point B. Right now this just feels like blah blah to you, but give me a second and I will explain everything. So let's take an example. Let's say our first point is A, it's at 0 plus 0i. Okay, so here if I have my complex plane, right? And my first point, we're going to use A is 0 plus 0i. So where is 0 plus 0i? Boom, it's right here, right? We're right at the center. That's 0 plus 0i. And my next point is 6 plus 8i. Okay, well 6 plus 8i is, I go 6 to my right and 8 up. Okay, so this is 6, 7, 8. It should be right here. There should be 8i over here. And here, if this is, let's do the example together. Here it says graph A. Okay, so this is A, right? This is B, right? B is my 6 plus 8i. This is B. And then what is the vector AB? You see here it says the vector AB. When you have this arrow symbol over here, this will be AB. So here I'm connecting A to B, and there is my vector. Okay, that's all a vector is, right? So here for part 2, what is the distance of the vector AB? If I wanted to calculate the distance from here to here, there is a distance formula in math that allows us to do that. And it's right here. It's D is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay? If you have seen this before, good. If you have never seen this before, don't freak out. So the first move we're going to do, just to get an idea of this is our first point, right? So we're going to say this is x sub 1, and we're going to say this is y sub 1. And I'm talking about the 0 and the 0. Let's do it in blue. Let the 6 be my x sub 2 and the 8 be our y sub 2. So here what we're going to do is we're going to take, oh sorry, this should not be an I, this should be a 1. Let's take these 4 numbers and plug them in to this formula. Let's see how it looks like, right? If this is my A and this is my B, again, this is my x sub 1, y sub 1. This is my x sub 2, y sub 2, right? It's right here. And let me just underline it again. We're literally going to substitute these numbers in here. So if I take my formula, this is it. So let's just follow the symbols, right? So first thing is the radical. First we do the parentheses. Now what's my x sub 2? X sub 2 is 6, so I put 6 here. Minus, what is my x sub 1? Is 0. 0, parentheses, squared, plus, parentheses, y sub 2 is 8, minus y sub 1 is 0, 0, squared. Okay? So then D is equal to the square root of 6 minus 0 is 6, so that's squared, plus 8 minus 0 is 8 squared. But then that's equal to, try and pause the video, what is 6 squared? 8 squared. You add these up. What is 36 plus 64? It's 100. Now, can we take the square root of 100? Yes, it's 10. Okay? So when we showed this before, this is the reason why 6 plus 8i, this distance from here to here, this distance of the magnitude of this vector is 10. Okay? Yeah. So let's say if I wanted to take the length of any vector, a plus bi, it doesn't matter what it is. Here, we took the length of 6 plus 8i with respect to 0, 0. Well, let's say if I put a plus bi and 0 plus 0I into my distance formula, right? So again, let this be x sub 1, y sub 1, and then let this be x sub 2, y sub 2. Let the a be x sub 2, let the b be y sub 2. And we're going to take these four things and then plug it into here. And let's see what we get. So again, d is equal to square root of, what I want you to do is pause the video and try and take these four and plug them into here, and let's see what we get, okay? I'm going to pause the video and do it for us. X sub 2 is what? A, so I put it here. What is x sub 1? It's 0, I put it here. So I just have a minus 0. A minus 0, oh, a minus 0 is just a, that's squared. Now look here, let's go back. Our y sub 2 is b, so I'm just plugging that in here. So I just have b minus 0. So this just becomes a squared plus b squared. So what does this mean? What does this mean? Right? Why did Mr. G show us this? Well, here, if I said the length of any vector is just a squared plus b squared, and you take the square root of it, let's take a look at this one. If I say, what is, let's focus here, what is the length of this vector 6 plus 8i? Let's just use our formula. This is my a, this is my b. So the length is just equal to the square root of 6 squared plus 8 squared, which is equal to the square root of 36 plus 64, which is equal to the square root of 100. Oh, sorry. Camera angle. Okay. Which is equal to 10. And we showed this over here, right? 6 plus 8i, the distance from 0 to 6 plus 8i here, that distance was 10. And we get the same thing here. Instead of using this distance formula in the what we used before, we could just use this. It's much nicer. The same thing here. Look, this is my a, this is my b. My b is the negative 8, right? So this is just equal to 6 squared plus negative 8 squared, which is still 36 plus 64, and that's 100, and that's equal to 10. What about this one? Try and do this one by yourself. Okay, if I have the length of this vector, right? I'm sorry, if this point, where is 5 plus 12i? This is 5, this is 12i. If I have that point here, what is the distance of this vector? Right? This is 5 plus 12i. What's the distance of this vector? Just use this. So this is equal to 5 squared. Remember, this is my a, this is my b. So 5 squared plus 12 squared, that's equal to square root of 25 plus 144, which is equal to square root of 169, which is just 13. Okay? You can check the math and it works. So we could just use this to calculate the length of any vector. Oh my god, that's amazing. Okay, let's move on. So here, we're done with this, we're done with this. Now let's go back to the textbook. So here, let's actually do the lesson for today. So what is game plan for today? I'm sorry, let me just grab my notes. And hold on, sorry, let me pause the video real quick.